All right, so we're on to lecture 9, and this is part B. So in part A, we learned how to name anions. Anions, those are negative ions. They come from nonmetals. Nonmetals form anions. Now, in today's lecture, we're going to learn about naming cations. Cations, those are positive ions, and we'll talk about those in this lecture. And then eventually, we're going to talk about naming compounds, naming ionic compounds in this lecture. All right, so let's go ahead and move on. And in this lecture, again, we're going to learn to name cations. So where do cations come from? Cations typically are from metals. Metals, when they become charged, they form cations. So cations, just to remind you, means positive ions. They're going to have a positive charge. Now, when we want to know about them, it turns out there's two ways that they can go. Some metals form always the same charge. So I'm going to call those my always and forever metals. Always and forever. So some metals always make the same charge. Other metals do not. They can have more than one charge depending on who they're around, depending on the situation. They're not consistent as far as what kind of charge they like to form. So there's some metals that are going to be not always and forever. All right, so there's going to be two possibilities with metals. Some metals always do the same thing. They always make the same kind of ion. Some metals don't. They make more than one charge depending on the situation. They can have, there's more than one option for them. All right, so first off, we are going to talk about how to name these, and they're going to be named differently. If you're an always and forever, we name you one way, and if you're not an always and forever, we name you another way. So just to remind you, we're just dealing with metals. That means we got this staircase thing. We're going to be dealing with stuff left of the staircase. And those are the metals. Now for the metals, the ones that are consistent all the time, let me tell you who they are. Those are things in group 1A. Lithium, sodium, potassium, that furthest left group, they always make a 1 charge, a +1 charge. All right, that's that group 1A. Now the group right next to them, the group with beryllium, magnesium, and calcium and strontium, I can count on those guys too. They always make a +2 charge. All right. Now, there's a few other ones that like to make the same charge over and over and over, always do the same thing. And they're actually a little bit further over on the periodic table, and it's not going to be the entire column. It's just going to be certain elements. Aluminum always is +3. It's a little hard to read there. Let me see if I can do better. It's a little hard to write on this and make it so you can read it. Let's see. Aluminum is always going to be +3. Gallium, I'm just going to write right over it, is always going to be +3. Indium is always going to be +3. Now, the next column right next to it, going a little left, they always do the same thing as well. Zinc is always +2. Cadmium is +2. Those guys are always +2. And then silver, I should say, Ag is always +1. I'm apologizing, so it's a little hard to read there, I know. I'm trying to write it right over the element. So silver is +1, that's element 47. Let me go over them one more time. Zinc and cadmium, those are elements 30 and 48, are +2, or 2+, I should have written the plus sign afterwards. And then the aluminum, the gallium, and the indium are always +3. Again, probably been better if I written the plus sign after the 3+. All right, so those guys you can always make the same charge. Now, any other metal, I'm talking about, I don't know, iron or chromium or titanium, or we could even go down here, lead. Anybody else, they don't make the same charge. They can make more than one charge depending on the situation. So with that in mind, how do we name these things? Well, if you're an always and forever element, if you're one of the ones I just highlighted, and let me erase some of these again a little bit. One of the ones I just highlighted, the way that we name you is we just write the name of the metal Oop, again, let me erase this. Write the name of the metal plus the word ion. Plus the word ion. So for example, if I asked you about Na+1, right? Oh, he's an always and forever. Look at where he is right here. He's a +1. All right. Or he's an always and forever. Or if I asked you about, I don't know, Ca. Ca is an always and forever. Oh yeah, he's in that column. He's always +2. The way I would name these guys is the first guy, Na+1, just called the sodium ion. The sodium ion. All right. Ca+2, what would I call him? He's just going to be called the calcium ion. All right. The same thing would be true for any of the ones that I drew in right here. Any of those guys, you would just say the aluminum ion or the zinc ion, any of those. All right. Now, what if you are not a consistent charge? Like, I don't know, let's do iron. Okay, let's talk about iron for a minute. Now, iron, which is right here, he doesn't always do the same thing. Iron, it turns out, sometimes in some situations, he'll have a +2 charge. In other situations, he's going to have a +3 charge, it turns out. How did I know 2 and 3? Based on some experience. But I can tell you that he doesn't always do the same thing. So when I want to name iron, I just can't say iron. Because which one are you talking about? The +2 fella or the +3 fella? I have to be a little bit more specific. So if you don't always do the same thing, I'm talking about anybody who's not an always and forever. When I want to call you something, the way I name you is I write the name of the metal, and then I also have to put the Roman numeral of its charge, plus a Roman numeral of the charge. Oh, I should have more room here. All right, of the charge. So the top fella, Fe2+, don't just say iron, because I don't know which version you're talking about. It is going to be called the iron Roman numeral 2. Iron 2, and I guess you usually write the word ion as well. The iron 2 ion. The other version of iron, iron with a 3+ charge, that's going to be called iron Roman numeral 3. Iron 3. All right, let me show you one more. Let me show you one more example. Another example. All right, another metal that does the same thing, and this got a little messy, so let me erase some of this. Okay, we're going to erase that. Another one that makes more than one charge is actually copper, right? That's not one of the ones I highlighted. Copper does more than one thing. All right, so for copper, it's going to be, there's 2 possibilities, it turns out. All right, so for copper, sometimes copper, I can tell you, it is going to be +1. And other times, other situations, is +2. So you got to tell me which one you're thinking of. So the way you're going to do that is you're going to have to use a Roman numeral, because copper doesn't always do the same thing. If you don't tell me, how am I supposed to know? So the top guy is called copper 1. And the other one I'm going to see, the other version that happens in nature, is called copper 2. Copper Roman numeral 2. All right, so with that, metals, we don't change the ending. They're not going to end in "ide." Those were the nonmetals. Those were the anions. What we do with metals is we just say the name of the metal, like you've been learning, the name of the element, but once in a while there's going to be a Roman numeral, all right, with things that aren't consistent. All right, there's one other thing I want to tell you about naming cations, and then we'll do a little practice of this. And that is for cations, for the ones that don't always do the same charge, the way I'm going to typically tell you the charge is I'm going to give you a Roman numeral. Roman numeral 1, Roman numeral 2. Sometimes you'll see people will do another method. Now, this method is sort of the old-timey method, and that is that instead of telling you the charge with a Roman numeral, chromium 2, chromium 3, for the two versions of chromium, right? Chromium, it turns out it can have more than one charge as well. Sometimes it's +2, sometimes it's +3. There is an older method that you still see around, and actually you'll see it around on things around your house. If you look on the bottle of multivitamins you have or something like that, sometimes the way they'll tell you which version, what the charge is they'll change the ending. They might hear copper 2 or chromium 2. Yeah, that could be chromium Roman numeral 2, but you also might hear it called chromis. Copper or chromium with a +3 charge, yeah, I could write Roman numeral 3, but you might also hear it called chromic, all right? So there is this other method where the naming does change, the ending changes. There is a pattern, if you're wondering. The us versions are the lower charged versions of an ion, of a cation. The ick versions are always the higher charge version. So how are you going to remember that? All right, well, us has an O in it, lower, that has an O in it. Ick has an I in it, higher has an I in it. All right, so again, same thing is true with copper. Copper sometimes has a 1 charge, sometimes has a 2 charge. I'm typically going to tell you which one I'm thinking of with the Roman numeral. Copper 1, copper 2. You might see somewhere around the world it called cuprous for the lower charge and cupric for the higher charge. All right, so this us-ick system, I'm not going to spend any time on it. You might see it once in a while in your everyday life, though. All right, so with that, let's kind of sum up what we know about charges, and then we'll do a little practicing. So let me get to another slide for that. All right, so a couple of critical things hopefully you're getting out of these first two parts of this lecture. One is the charges things make. We are going to need to know these charges. We're going to use them all the time. You need to know what kind of ion elements like to form. All right, so let's review that. I know in the last slide maybe it was a little hard to read. So first off, nonmetals. Nonmetals always make negative something. So nonmetals always form anions. All right. Now, let's be a little bit more exact. This column right here, fluorine, chlorine, bromine, iodine, these guys make -1 ions. The next column over, the oxygen, sulfur, and selenium ions, they make -2 ions. The next column over, the phosphorus, nitrogen, and all these guys, they make -3 ions. All right. If you're wondering, like what about the noble gases, the first column? Sometimes people say, oh, well, they don't really form ions, so you could think of that as like being a 0 almost, like the column 8A. All right. Now, other things I want to tell you about is, well, metals always form the same ions sometimes. Sometimes they make the same charge, okay? So for metals, ones that always do the same thing, well, first off, all metals will form cations. And if you are in this column right here, I'm talking about cesium, rubidium, potassium, sodium, all the way up, you're going to make a +1 charge. If we go to the next column over, I'm talking about barium, strontium, calcium, magnesium, beryllium, you're going to make a +2 charge. If you are a few of these weird ones towards the middle, you always do the same thing. Aluminum is always +3, so is gallium. And then, oh man, I did the same thing again. I'm going to try to be better. All right, I should really be writing the plus sign afterwards. Aluminum is always +3. Gallium is always +3. Indium is always +3. Now, how about a few other ones that always do the same thing? Well, right next to them. Zinc and cadmium are always +2. That's a 2 there. It's a little hard to read that. All right, that's a 2. Maybe if I try another color. Well, try to make this clear. This is important. All right, zinc is always +2. That shows up a little better. Cadmium is always +2. And then there's one more, and that is right next to it. and that is silver is always +1. Silver is always +1. All right, so any other metal is not consistent. I'm looking at you, manganese. You don't always do the same thing. I'm looking at you, cobalt. You don't always do the same thing. Even though fellas down here, lead is Pb. That doesn't always do the same thing. So the ones that I wrote in, you can count on. All right, so with that, let's do a little practice about what do we call these charged particles? How do you name them? All right, so by the way, if you haven't written these down, super important. You might pause this video. You're going to use these charges all the time. You need to know these charges. So if you haven't jotted them down somewhere, I would definitely do it right now. All right, with that, let's get to our practice. All right, so for our practice, you got to know what to name these things. So let's do, I'm going to put up 4 of them actually. All right. And these are ones, again, I'm going to get you to think about and answer. So we'll do our little pop-up questions on these. So Be2+, what do you call it? S2-, what do you call it? Ti4+, what do you call it? And then Pb3-, what do you call it? All right. So you could pause the video if you want for a minute and think about these. And then you're going to get your little practice questions that you got to answer. They're going to start showing up here in a second. So you might pause this and think about them, and then you'll have to answer them. Find them on the periodic table. Hey, I'll help you with that. Beryllium's right here. Sulfur's right there. Titanium's right there. Phosphorus is right there. All right, right there. All right. All right, you had a chance to try them. I hope you got them right. Let's go over it just to confirm, make sure it makes sense. All right, first off, anybody with a negative charge? Anybody with a negative charge? What do you end in? You're going to end in "-ide". All right, so an element with a negative charge ends in "-ide". Sulfide. P with a negative charge. An element with a negative charge is going to end in "-ide". Phosphide. Negative things end in "-ide". Now, what about positive things? Positive things, metals with a charge, they will not end in "-ide". They're either going to be just the name or they're going to have a Roman numeral. Now, I have 2 metals on this list. I've got beryllium and I've got titanium. Beryllium is an always and forever. He's in that column that always makes a +2. If you're an always and forever, you just write the name. So this is going to be called beryllium, the beryllium ion. Titanium was not an always and forever. So you have to tell me what charge he's making in this situation. Titanium, all right, is not an always and forever. That means you use a Roman numeral. And the Roman numeral for 4 is IV. Roman numeral for 4 is IV. That's the Roman numeral. All right, so hopefully that makes sense. With that, that's naming ions. That means we're ready to name ionic compounds. Ionic compounds contain ions, so it's going to be using this as we write formulas for compounds and names for compounds. So that'll be in the rest of our work today in this lecture. We'll get to naming compounds now that we have all this background. All right, part C coming up.